Welcome to this first section. Now here we are going to see the situations where you have to find the rule of a geometric progression. You have the geometric sequence being given you, and you just need to input the values of, let's say, the first term and the common ratio, and just try to use that to simplify the kind of geometric expression that you've been given. Let's see in the first question. For the given geometric sequence, find the common ratio and the next two terms, and hence find the nth term. A, 3, 6, 12. B, x squared, x, 1. Under geometric progression, like the question just showed up there, we are going to look at how the general term of the geometric progression would be used in trying to work out problems, or how to find that. So the first question that's mentioned to you that a geometric sequence has been given and we want to find the common ratio and the next two terms. Let's look at the kind of sequence that we have there. The first in the list of the sequence that you were given is 3, 6, and 12. Okay, so 3, 6, and 12, and you are being asked to find the next two terms. So the next two terms, and also the nth term. Okay, because it is a geometric sequence, what we have to know is that there is a multiplier effect. That's essentially what a geometric sequence means. Unlike the AP has an additive effect. Even when it is negative, you are adding kind of a negative number. It is additive. A geometric sequence is a multiplicative effect. So that constant that you would have had in an AP where you were adding or subtracting, in a geometric sequence, we are rather multiplying. So when we want to find what is common, the AP, in the case of the AP, we would have to subtract the differences, okay, try to find the difference. Then here, because it is multiplicative, we don't have to subtract, but we rather have to divide so that we know how it goes. All right, so the question says that what are the next two terms? So we divide the second term over the first term. Our common ratio is going to be 6 over 3, and that will give you 2. So 6 over 3 giving you 2, and we know that, as we were just shown in the introductory part of the geometric progression, that the nth term of a geometric progression is always a to the power r to the power n minus 1, where n refers to the term that we are interested in. So when we want to find the next two terms, what happens? We just multiply it by 2. Okay, so the next two terms for our expression will be 12 times 2 will give you 24. Then 24 times 2 will give you 48. Okay, so these are the two terms, the subsequent two terms in the sequence. The question says that we should find the nth term. The nth term means that since it represents how a geometric progression is, we take the general form of a geometric progression and try to simplify by replacing the parts where you have the common ratio and the first term. All right, so the nth term of a geometric progression, Tn, will be A, which is r, our A, which is 3, times our r. Our r is 2, so 2 to the power n minus 1. 2 to the power n minus 1. Okay, so that is it. Remember, you don't multiply. You don't multiply to give you 6 n minus 1. No, it is 3 times 2 n minus 1. So sometimes, to avoid the confusion, just write 3 into brackets 2 n minus 1. Remember, in indices, when the bases are not the same, we cannot just put together the exponents. Okay? If you have any challenges there, you can just go and review the videos or the lessons on indices, and that should clarify any difficulties there. All right, the second part also has another sequence, and this sequence was of the form B. The sequence was given as x squared, we had x and 1, and we wanted to find the next two terms. Again, when you divide x over x squared, what do you get? X over x squared is going to give you 1 over x. So this is our common ratio, 1 over x. The multiplicative effect, the common ratio, that constant that is used to generate the terms successively is 1 over x. So our next two terms will be 1 times 1 over x. Okay? Let me just change that. 1 times 1 over x. That's going to give us 1 times 1 over x will give you 1 over x. Then times another 1 over x will give you 1 over x squared. Okay? So these are the two terms. Similarly to the first part, we are asked to find the nth term of the GP. The nth term of the GP. So we just go back and take the general term of a GP. Tn is equal to A. Why do I keep writing a to the power r? Forgive me. AR n minus 1. So we'll take our first term. Our first term is x squared. We'll put x squared here. Times, please, it's not point. Times r, which is 1 over x all to the power n minus 1. Okay? 1 over x all to the power n minus 1. So we should be able to resolve that since the denominators are common, or it has kind of a constant base there. So let's just try and see if we can resolve. This is going to give you x squared times x. Just the bracket is going to give you minus 1, okay? N minus 1. Then you're going to have x squared dot x. So you put the minus 1 there. That's going to give you minus n plus 1, okay? Since the bases are the same, we just add the exponent. So our nth term for this is going to give you x, then 2 minus n plus 1. What does that give you? 3 minus n. Okay, so 2 plus n minus n plus 1. That's going to give you 2 plus 1, 3, then minus n. Okay, so this is the nth term of the geometric sequence. You understand that? So guys, for this section, that's what we just want to do. Anytime you are given a geometric sequence, you should be able to find the general formula or re-simplify the general formula when you know the first term and the common ratio. Just slot them in there. Take your time with the algebra. Take your time with the algebra. You should be able to arrive at the answers neatly as you have them presented. Okay?